Good morning from here, and then good afternoon to all of you over there in Nigeria. I'm so happy to be amongst you this morning slash afternoon. And I'm glad to be home because this is home for me. I'm super, super excited. So let me first of all start by wishing everyone a happy International Day of Mathematics, the 2024. The theme of the 2024 International Day of Mathematics is playing with maths. And as you know, each year the IDM they get a theme for the celebration, and this year it's what? Playing with maths. And not only that, we want to play with puzzles, or maybe we want to have some entertainment, some math games, and all that. We want to play with maths itself, right? We want to explore, we want to experiment, and then we want to discover and invent new things. So these are the ideas of playing with maths. And then I want to also thank the organizers of Mathematics World of Excellence, led by Mrs. Ezama Genevieve, for the warm invitation. We see all that you do. It's not easy trying to promote mathematics and drive STEM related discipline down there in Nigeria. So all the activities going on, the seminars, everything, we see them, and we are grateful to you and your team for making sure that this thing is happening. And in due time, we are going to partner fully with the team. I'm already a member of the team, by the way, so I'm part and parcel of everything. I'm following, and I'm happy that we are here. Gradually, we are going to arrive at that desired goal, because you know the purpose. We want to establish a mass institute, a STEM hub down there in the eastern Nigeria, Oka, Nigeria. So this is going to happen soonest, I tell you. So I'm happy that this is here, and I'm happy also for the invitation to be the guest speaker for this year's International Day of Mathematics. So, what is IDM? As you know, IDM is already celebrated every year on March 14th, right? And popularly known as what? Pi Day. I'm not sure why my while it's not moving. Yes, I'm glad it's moving now. So known as what? Pi Day. And we celebrate it in many countries around the world. It's popular. It's the name Pi Day came from the number that you are seeing on that screen, popular number pi, right? Which is simply the what? The ratio between the circumference and the diameter of a circle, which is approximately 3.14. And that's where that name came from. So all that we do, it's just to celebrate the beauty of mathematics, to promote mathematical activities, to create awareness, to tell people about maths, its values, its importance. Why do you want to study maths? Math is every day, math is everywhere. So these are the kinds of things that we do on a day like this to celebrate this particular day. Last week it was International Day of Women. I think in the International Women's Day, we celebrate women, we celebrated mothers. And this week we are saying it is International Day of Mathematics. We want to tell them to the world out there that, look, you cannot survive in a world like this without maths. That is what it's all about. Because if not for maths, we wouldn't have computers, right? And if not for maths, um, we wouldn't have know how the proportions that you are going to use to cook what you want to eat. So in every aspect of our lives, we see maths there. That's why it's important that we speak it. We encourage students. Such a time like this, you can see that students also don't like to study maths, right? For example, those in high school, they will be like, why are you always asking us to find X? Why, each time find X, we are looking for Y. I remember some people would normally ask me to say, Alex, every time, how did you manage to come up to this place to have a PhD in maths every time you are looking for X, you're looking for Y? What is most people don't know the beauty, the background behind it. If you know the background behind it, then you will know the reason why math is important. They just thought it's just a waste of time, or they just thought that maybe when they go to the university, they are not going to do. But no, we are here to tell them that such a day is dedicated to say, look, those things are wrong. Those ideas, those notions that you have about mathematics, it's wrong. We showcase to say, look, math is in your room. But for you to do some designs, for you to even build in this 21st century, math is everywhere. So and then we encourage people to value math. We encourage people to study. That's the essence of a day like this. If you look at my screen, by the way, you will find out that there is something that I wrote there codedly. And it simply said, I ate some pie today, right? That's the beauty of it. Because it's a pie day, I encourage you, make sure that there is some pie for you to enjoy at the end of the meeting. And moving forward, I would like to also take this opportunity to congratulate my one-time erudite professor, Professor Eric Owadiegu Ofedu, right? Congratulations on the launch of your new book, Mathematical Analysis, A Gentle Introduction. I must say that we've drank from your well of experience while we are there. And we are happy to see that you still have the interest, have our interest in your heart, because most people at your status might not want to um, do this, but you felt the need that, look, there is a missing gap. I need to compile this and then show these people that if you have this, if you have this book, it will guide you. And I must encourage everybody, make sure that you have a copy of this book, because it's going to help you. Without mathematical analysis, without having that knowledge, there is nothing that you are going to do. Whatever you think that people are doing out there, the knowledge of mathematical analysis, the knowledge of the basic maths, the knowledge of the pure maths, it's very necessary. It's essential. And that's why I said this is needed at a time like this. It was well thought of, and we must say kudos to Prof. Eric for that. And in due time, we're going to launch, and I'm going to make sure that some persons have access to these books, because if you have access to it, make sure you are building your library. Make sure you go get close to Prof. Eric, get close to other lecturers in the department, get close to other mentors with in the math world of excellence, and you will learn a lot from their wealth of experience. Okay. So let's come now to the main thing that I am asked to do today. So the organizers, when they sent the email, they said, okay, we want you to please speak on the importance and values of mathematical studies with insight on career paths. So I was like, okay, since the theme of this year's conference, of this year's celebration says playing with maths, exploring, experimenting and discovering, I had to now change the title a little bit to say exploring the world of mathematics, importance, values, and careers. And by the way, as a way of gentle introduction, I am Dr. Alex Alochukwu, originally from Nigeria. So I am from Oba in Idemili South local government area. And I had my first degree in Nnamdi Azikiwe University, Oka. I graduated from there, I think sometime in 2010. And then from there, I did my NYSC, did a master's with AIMS in Ghana. Then I did a master's again in computer science the University of KwaZulu-Natal, then proceeded to have my PhD at the University of Johannesburg, and then did some lecturing over there, did some postdoctoral experience back then in South Africa, and then did more of research. And then here am I at the Albany State University as an assistant professor of mathematics. So it's my pleasure to be your speaker at this IDM 2024 celebration with the Mathematical Sword of Excellence. And thank you once again for having me. So I do not, the way I arranged my talk, I decided not to have an overview, right? But I'm going to just go around the beat and then show you some of the things which I've compiled here. If you remembered while we are growing up, we have that notion, oh, if you see anybody that is reading mathematics, oh my word, that person must be a mad person. The way they behave, it somehow, or maths is too difficult. Why are these people studying this? Why do they have interest? You know, even when you're in primary school or you're in secondary school, we assume that mathematics is one of the most challenging subjects. People don't want to study it. People don't want to read it. And that's a problem, right? But in as much as we assume it is not it's one of the challenging subjects, there is always the acronym that I normally tell people: master all the hypotheses. Math. If you are able to master all the hypotheses, if you have a theorem, know what the statement of the theorem is saying. If you have a definition, what does it say? Where can I use it? Where can I apply this? Once you know this and know how to apply it, then you will find out that it's not difficult. So, in as much as people think that maths is one of the most challenging subjects, it plays a crucial role in our present day world. Right from the olden times, the history back, when you go back to the history and then up to this moment that we are, maths plays role. We see maths in our everyday life. You want to eat your food, you want to measure how many spices you are going to put, you want to pay somebody that did for you, you want to enter, all these exchanging expenses, managing your schedules, these things have to do with maths, right? So regardless, it has several important values that we need to be aware of. And that's why I said, why are we studying mathematics? What's the difference? So why do you think that they put mathematics in the curriculum? Why do you think it's necessary? Why? Because look, it's a chain of action. From your primary school, you are introduced to mathematics at the kindergarten. Remember, I have a son, by the way, he's in kindergarten now, and I watch him come back and I marvel at how, those kind of problems, reasonings, and all the things, I see how he puts in some puzzles. These things helps to stimulate the cognitive development. So you can see, because if it's while you are in the kindergarten, so they are not giving you the high level maths, they are bringing it at your level. Then when you move to grade 1, grade 2, and all that, you still repeat the same idea, you still repeat the same concept, but now it's now beginning to become more advanced. It's still the same thing that you learned in kindergarten that we are still talking in grade 1, 2, 3, and 4, but in a different way. So you can see, and then when you move to grade 9, JS1 or maybe JS2 and JS3 and all that, what are you seeing? You will see that It's still the same topic. You did fractions, you did ratios, you did proportion, you did simple interest. We are still talking about this, but we are bringing it in different angles. So the reason one of this is that what? It stimulates you. It enhances critical thinking. It increases your knowledge and awareness of your mind. And then when you now come to maybe in the, as people progress, people have different interests. Some want to become a medical doctor, some want to become maybe a physicist, some want to work in the bank and all that. And some also want to study maths as a degree. But does that stuff mean that you're not going to see maths in those places? No, maths is in all of them. So one of the reasons is that it fosters logical reasoning and analytical skills, and it develops key employability skills. Why? Because by the time you are doing problem solving, by the time you are doing teamwork, you learn how to communicate, logical reasoning. You don't do things anyhow. When you learned about simple interest and compound interest, it helps you to make decisions. So when you want to buy something, when you want to make some investment, what are you doing? You are telling yourself, okay, no, I need to be wise with my decision. I need to do this. No, I can't do this because of the knowledge that you already know. And where is that knowledge coming from? From the maths that you learned. It provides you what? A foundation for other various disciplines and industry work that you want to do. So, for example, you want to be a medical doctor. If you don't have the basic knowledge of maths, how then do you want to prescribe your drugs? You see where it comes from. Even somebody that is doing music, right? You want to create you want to compose some music. What are you? You need to understand the nature of fractions because you're working with beats. So if you don't know your beats correctly, how to sum and add all those things, even those in sociology, what happens? You need to know how to analyze some of the reports. When you go and do interviews, people, these are things that you need. So in as much as you think, people think in quotes, we don't see maths there. Maths is in all those. It leads to versatile qualifications because once you know maths, you can be able to do other things. All right. So the next one. So you can see many subjects and disciplines use maths. You have maths in physics, in business, in biology, in economics, in everywhere you can think of. Apart from the subjects, disciplines, in fact, anything that we are doing now, even the recent AI, machine learning, data science that you can think of, maths is there. You wouldn't believe it, but that is the real truth. Maths is in all these places. So mathematics is what? The queen. Some people say the queen of all sciences. Some people say the mother of all disciplines. So maths, it's the queen and mother of all disciplines. So you see, also, if I'm going to become a lawyer, I need to argue my way around. So when you are arguing, you are doing maths, right? You are doing logic. You are using those basic strategies that we know in maths. Logical reasoning, deductive reasoning, inductive. These are, when we say proof by induction and all those things, that's what you are doing. You're laying your arguments right. In engineering, in several places that you can think of, maths is there. So you can see these are, so because maths is, so it's like, every other thing that you have is built upon this. So it's the foundation. It's the foundation. So so look at it, you are building a house. You want to build a house, and if the foundation is not right, then it will collapse. So for you to excel in different areas that you can think of, you must have that knowledge. So if you are a secondary school student in the audience, please, I must advise you, make sure that you take your math serious. I know in Nigeria, while we are there, we only had maths and further maths, and we have all other things encompassed. But over this side that you see, while I was in South Africa, there is, they try to make it simplified. They have the tech maths, they have the mass literacy. They try to categorize it, and they now give the students the option to select the one that they are going to take when they want to do their matric, which is like like in your exam, in your WAEC, you ask you, which one do you want to do? Of course, you must pass maths before you can do. The math is one of the requirements. But here they will tell, okay, do math literacy or you do math this. But when those students come to the university and they see that they can run away from maths, it becomes a problem. So I normally tell them, I said, if you have people back there, make sure that you tell them, do not just take just one part of maths. Make sure that you do all focus, because you don't know the one that you are going to see. Because some people will say we have core maths, we have AS level maths, we have maths literacy. I just take some of these just to show you the option that some of these people have. Some people will say, oh, let us just take the part of the maths that focus on data analysis and statistics techniques. Some people will say, let us just take the one that just do the big, because we are doing humanities, I just want to do maths literacy. But we don't know that in the curriculum that you are going to do in the university, there are other things there. So my advice is that when you are doing maths, make sure that all the components are there. Algebra, geometry, calculus, trigonometry, financial maths, all the probability statistics, analysis, modeling, estimation, measurement, functions, sequences. Make sure that you have a grasp of all this, because it will help you. You don't know where you're going. For example, those in data analysis, those in machine learning, they are using regression, they are using statistics, they are using matrices, they are using algebra, abstract algebra, linear algebra, and the likes. Even measure theory, some of these things that you think that you don't use. Some people, okay, there is a places that you're going to do, you want to see modeling, you have to use calculus, differential equations, integrations. So my advice would be, don't leave out anyone. Make sure that you get a handful of all of this. So when you see something like this, right, you know that what we are talking about is what? It's maths. That's the kind of things that we are talking about. Okay. Now, some areas of mathematics which I just want to point out for those of you that are now going into the university, or those of you that are in the university. You might have already heard about pure mathematics. You will hear about applied maths. You will hear about statistics. You hear about computational mathematics, right? You will also hear about quantum maths, quantum mechanics. All these things are just subset of mathematics. So maths is like the bigger set, and then we have subset. So as you now navigate through your studies, through your mathematical studies, you are going to ask yourself, okay, where numerical analysis, differential equations, mathematical modeling of no, which one? Even image processing, signal processing, mesh data analysis, all these things are just subset. They use maths. So you ask yourself, which one of them should I use? That is what we mean exploring. And that's why you see that the university or they have the curriculum that helps you to do what? To achieve, to make selections. So when you go, for those of you that are already in the university, you see that they are going to say, do these electives. They have the main core ones that you want to do, that you want to select. But make sure that do not restrict yourself to just one. Don't just be, yes, but I must tell anybody, if you want to excel, make sure that your background in pure maths is very important. And that's why I must encourage each and every one of you to make sure that you have an access to Professor Eric Ofedu's textbook. Because I remember these textbooks are going to help you when your background, when your foundation in analysis, it's in a pure math, algebra, it's well grounded, then you can excel in it. And that is why we're excelling, because most of these things are no longer difficult for you because you have seen it. And that's what you are going to do. So pure maths is there. And then applied math is just the mathematical method and techniques that are used in practical applications. So when you talk about studying some mathematical models, developing models, algorithms, or computational techniques to solve some real world problems, that is where engineering, physics, these are where applications of mathematics comes in. And even in our recent world, even COVID, we use maths to solve COVID. We use maths now in drug design, right? We use maths in biology, in crime, in anything. So there are a lot of things that you can do. So choose the one, explore the one that suits your interest is the one that you should go for, right? Okay. Statistics is just about reaching conclusions from data in order to what? Make informed decisions to help plan for the future, right? So when we want to make some informed decisions, that means you need to collect some data and all that, all right? So what is the probability of two 100-year floods happening within the space of 5 years? So you need to collect your data, you need to make some assumptions, and then from there, you need to begin to analyze and then try to see if there's a correlation between them. And someone mentioned that the majority of private sector organizations believe that the use of data analytics will be the most important factor in increasing growth in UK businesses, right? So this is just to show you where these things can be used. Even mechanics, some of us also did mechanics while we were in school. You are saying it is the mathematical, it is the modeling of the world around us, the motion of objects, and the forces acting on them. Carry, when you have interest in going into physics or when you have interest in delving into engineering, then you must know that when you are selecting some of the courses that you want to do, you're selecting things around this area. Okay, that has to do with this. All right. For example, you can see this problem I put here. A golfer drives their ball from a tree on the horizontal ground so that it has an initial velocity of 50 meters per second at an angle of 40 degrees above the horizontal. How far down the fairway will the ball land? This is a mathematical problem, but it has to do with what? Motion of objects around us. And these are the kind of things that those in physics have interest in. So if your passion is in terms of this line, then it means that you're going to select things that has to do with mechanics. If you have passion on solving real world problems, then you do go towards applied mathematics or computational mathematics. If you have interest in working on the main thing, developing the theorems that people are going to use, because those in data analysis, those in machine learning, those in deep data science, they use some of these theories. Then you go to pure maths because you want to make sure that the proofs are correct. You want to make sure that the correctness of the proof, you want to ensure that these theorems, it will hold for in any situation. Then you go into pure. Right? If you have interest in finance, investment, then you go into financial maths. And if you have interest in data analysis, trying to make informed decisions, stochastics, you go into statistics. So in as much as some people have statistics as a course, they make use of maths. If you have interest in diseases and all that, you go into what? Disease modeling. We have maths modeling, maths bio, we have biomathematics and all that. There are a lot that you can explore, but it depends on your interest. What do you have interest in? What do you want to do? So this is my own area. I'm more interested. I work now more on discrete mathematics and combinatorics, right? So many of the problems that we work involves optimization, operation research, and then we want to find an efficient solution. In fact, some of those things we can actually describe them as networks, right? We can actually describe them in forms of graphs, points, and lines. This is what, so you can say, okay, now I have a, for example, network of friends. I can analyze to say, oh, this is how close related you are with this person. Or I can even say, okay, I can call my houses the nodes, and then the roads that leads to the houses is what will become the edges. And then I can assign weights to say these are the weights. Or maybe I can even look at it in terms of the cost. The weight can be the cost of doing from here to here. All right. So I can, for example, what would be the most efficient route for delivering posts around this network of streets? Now look at the network of streets. This involves optimization. So you can see I can model it in forms of graph. I can also use integer programming or use some other things to just find the efficient routes to do this. This is kind of this. So if you have interest in this kind of things, then you know that what you are going to be doing, you are going to be going towards what? Discrete or decision mathematics. So if you, while you navigate through your studies, while you are making your decision, while you see your interest, what are the skills that you develop when you go through mathematical studies? Problem solving skill is there, critical thinking is there, analytical reasoning, attention to detail, adaptability is all there, and communication, because not everybody wants to hear. Let me even start with communication. Most people are afraid to do what? To listen to maths because they don't want to hear you talk about epsilon. Now, this is where I'm sure Genevieve has some of my science communication. Recently, over the past 2 years or thereabout, I enrolled in some science communication, trying to communicate what we do in our research center to the public, right? So that's what we call science communication. Yes, we do a lot of maths in the background, but investors, people that want to give you grants or people that want to fund your projects, they don't want to hear those maths. So you should find a way to convey your complex ideas, your mathematical ideas effectively to the people. And this is one of the things that you learn when you go through the mathematical studies, because you are trained to know how to write. Even after doing your computations and result, you have to communicate. So that's why those in the academic publish reports. Then you want to you want to get some funding, you need to pitch. So adaptability, you apply mathematical principles to diverse scenarios. You must precision in work, attention to detail. When you see a mathematician, he analyzes everything. You minimize some error. You don't just jump into everything. You think before you act, right? You tackle complex. So that are the kind of skill. These are some of the important, because those skills, you will use them in the industry. Anything that maths, the skills that you learn while doing maths, it's used in the industry. And that's very, 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 very important. Okay, so I'm gonna pause a little bit and then see if there are, I'm gonna pause a little bit and see if there are questions, or if there are things, if there are things that I don't want to just I don't want to just keep going, but I've talked a lot, right? But that's it. So I'm sure what I'm saying is making sense to you. Okay? It's making sense, and that's it. Okay, now let's go to the values of learning maths. Okay, what are the values that we can take in learning maths? So I said value are simply defined as what? Importance, usefulness, and what of something. And values of learning, they are simply what? Outcomes or result achieved after learning. And I said here, there are 6 values, right, that we get by learning mathematics. So we have the cultural value, we have the aesthetics value, we have the social, we have the moral, we have the disciplinary, and we have the practical value. All right. So when we talk about social value, look at it. Math plays a crucial role in shaping our social interactions and relationship with others. Think about it. So when you do maths, then you know that, okay, right? It fosters, there have, when you, some of a group problem solving, you communicate, you work together. That's maths helping you to know how to relate with people because everybody cannot be the same. Culture, right? When we talk about cultural values, math is embedded in our cultural values. It's left for you to go around and do what? To appreciate the beauty of maths. In that, when you study the history of maths and then you gain insight into some cultural context in which mathematical ideas emerge. You just gain insight. Oh, this is why sometimes, oh, this is because of this led to this. Oh, there are some issues in the culture that made people to start solving a particular problem. Oh, how do we cure this? This is a problem. Oh, this you learn about it. When we talk about aesthetics, we're talking about what the beauty, the elegance that transcends its practical application of maths. In architecture, in the symmetries, when you look at all those things, it's just maths. You think those people that are doing bricklaying and all those things, do you think they're not doing maths? No, they are doing maths, and that's the beauty. Patterns, recognitions, and all that. There are some morals that math also imbibes in us. I don't want to dwell more on all those things. And then there are some, when you think discipline, when we talk about discipline, this being disciplined in the way you are thinking, in your logical coherence, in your, it's some of the things that we get from maths. And then when we talk about the practical, you cannot negate, you cannot, it's indispensable. Math is indispensable in everyday life. It has numerous practical applications across various fields, whether you are in the science, whether you are in engineering, whether you are in finance, technology, you want to design bridge, you want to calculate your expenses, you want to do navigation, GPS, whatever. Math is playing every math has its role there. What when you want to cook, for example, what are you using? Your knowledge of what? Ratio and proportion. For those of us that has garden or those ones, it's knowledge of measuration that you are using. When you want to do budgeting, you need to know about finance, income, expenditure, plus and minus and all that. You get some laborers to do some work for you. What are you doing? You have to have knowledge of savings and earning. You don't want them to teach you. You go for shopping. You want to know how do I maximize, or you own a business. You want to know how do I, apologies, oh, my phone is ringing. How do I do what? How do I maximize profit and then minimize cost and everything? Even in sports, excuse me, those of you that analyze sports, these are things that practical knowledge of probability is there, statistics, navigation. You want to know coordinate geometry. These are practical applications of maths in architecture, in banking, in industry, even in weather forecast. Maths, maths has applications there. Excuse me. And that's why I said maths is everywhere. Okay? Or even in modeling, natural disaster, those that are working with surveying, growth and decay, you want to predict what will happen. You observe trends. Even in COVID, majority of mathematicians played role in COVID because we using what math. We are looking at, okay, we need to know how does this disease spread? What do we do? And then people develop model. and then begin to analyze and then say that is how we come about, you must be 6 meters apart, you must be this one. They work with doctors. Even now, for example, in what I'm doing, uh, to get a drug is a problem. And what do? We say, no, we don't want to spend money again to go to this. All we know is that if we find out that these are the compounds that can be potential in curing one of the diseases, we take that compound, get structure of the chemical compound, translate it, model it as a graph, and then we analyze using some of the topological indices. And then what do? We now take these things and then go back and then say, okay, we create a model. Oh, this is the ones that we take. So instead of taking all the compounds, we have reduced it to some and say, this is what we identify from these are the good ones we can identify. You do some docking. Maths has numerous applications. So we can negate it. And these are one of the values of learning. But when you go to, some of us, even when you go to your internships, it is the knowledge of math that you have. Internship, ITs, and all the industrial attachments, it's knowledge of what you get. You see it applying in everyday life. It's everywhere. I just took out these pictures from um, American Mathematical Society website just to show you some of the things that are being powered by maths, right? In transportation, in entertainment, in energy industry, in medical research, in information technology, space exploration, they're uncountable. So you can see it has a benefit. So if somebody, so remove that notion that, oh, I am only going to study maths because I want to become a mathematics teacher or a mathematics lecturer. No, there are several opportunities. Everybody has their interests. Yes, we have people that will become maths teachers. We have people that will become maths professors that are going to do what? That will show you the way. But you on your own, discover yourself, discover your interest while you are doing the math study, right? While you are, okay, this is what I'm reading. I think I need this. I think I need to go into this line. And then you will see when we go through when we come to the point of numerous careers opportunity, you will see that there is never a place you are not going to use maths. There is high demand for mathematicians, especially those that take serious of what they are doing. Even those that are in the academic, they have been also sought for. I remember that Professor Eric is also one of those that went to the Eric. I remember there was a time Professor Chikamo was also invited to be among those that are when there was an issue in the election procedures or something of that nature. It is his knowledge of math because he's a mathematics professor. He has to be invited. We need you here. We need your expertise here. And some people they consult, the companies will also consult you. We are stuck. Can you recommend those that can work on it? We want to pay you. We want you to sit to work on these problems. So don't think that those professors that you are thinking, those lecturers, that they are not useful. They are also useful. But everybody will not be. So find your niche and follow that one. That's the point I'm trying to say. If you want to pursue advanced degrees like myself, you are welcome to pursue advanced degrees, in mathematics, applied mathematics, you can do masters, but you have a role from BSc to masters and to doctorate. And please, I know most of us in Nigeria, in quote, we always want you do BSc mathematics, then I must do MSc mathematics, I must do PhD mathematics. Over this side, once you have that basic maths, you can switch. That's the thing. They will help you because your basic maths will help you to know where you can be. There's the what they call you use this. You have interest in this. Then they look at the courses that you did and okay, you did these courses. This courses is relevant for this, and then they will tell you the courses that you need to do. That's how you navigate the process. You try to, okay, you must collaborate with institutions. I have a friend here in Texas. He was called while he was doing his postdoc. He was called by the city to help to analyze the problem that they have during COVID. And every day you see him on the news. So you collaborate with research centers, you expand your academic horizon. Do not limit yourself. That's the goal. That's my message. Don't limit yourself. Make sure that you expand. You advance, right? Advance in your careers. If you don't want to pursue advanced degree, make sure that your BSc is well, not just two or pass. Get good grades. Don't just read because you want to read and move, right? Make sure that you understood the concept, you can apply it. And then while you go to that place that you want to go, explore. All right. So I've outlined some career paths in mathematics. You can become a mathematician, or if you want to tour the time of statistician, actuary, or software developer, or financial analyst. But aside these ones that I've outlined here, I'm looking at my time. I think I've already exhausted most of the time. Dear, I want you beyond traditional careers and classroom. Uncover unconventional paths. Maybe something in a cryptographer, game developer, operation research analyst. Do something. Look at it. There are many. There are many. In fact, I can show you my backboard here. There is what I wrote here. What can I do with a math degree? Animator, urban designer, commodity trader, banker, forensic analyst. You can be actuary, you can be epidemiologist, GRI, a lot of them. Point it is, you can do, what can you do with maths career? Once you have that maths, once you have a knowledge of maths, there are a lot of opportunities for you. That's what I said. Do not limit yourself. Stockbroker, air traffic controller. In fact, I also put on the screen, later they're going to share the slide, some careers where maths is being used currently. All right, in technology, in the medicine, in the medical field, game design, internet security, cryptography, artificial intelligence, maths is being utilized. Aircraft modeling. While I was doing my master's in UKZN, I worked on air traffic flow modeling. I had to go to the airports. We want to see how we can reroute flights when you have traffic congestions. And we model it using neighborhood search algorithm, and then we did some things over there. Fluid flows, acoustic software development, these things, this is ongoing in engineering. Maths people are needed there. So there are a lot of things that you can do. Modeling diseases, I've mentioned about this before, quantum physics, astronomy, DNA sequencing, maths is there. These are the new ones that are coming up. Even drug design, I forgot to put it there, but these are careers using maths. So there are a lot of several opportunities out there for you. All right, data science, psychology, I've mentioned it, climate change, environmental modeling, everything is there. Okay. So in conclusion of what I'm saying, I'm simply saying there are a lot of opportunities out there. Do not, a lot of career paths that you are going to navigate through if you study by studying mathematics. But while I was talking about advancing your degree, I'm also simply saying there are resources out there. Don't just leverage online. Your phone, you can study from your phone. There is Coursera, there is there are a lot of them, Coursera, Khan Academy. There are a lot of things that you can, people do go to YouTube and all that, but I don't normally advise, make sure that you go to one that you know that you are sure of what the person is doing. If you need some textbooks, if you need some books, there are organizations that can send these things to you. Join, build a network, enhance your skills. That's the thing. Learn new things. Don't just sit and say, okay, no, let me just do it just because I want to get the master's degree and then I will go. No. Learn programming. And that's why we have mathematics word of excellence, because we want to establish these things there so that we bring people to train people so that we don't know that you don't just come and just cram everything and leave. Seek guidance from mentors, professors, and professionals in the field. They should tell you the way to go. Build yourself. and then you sell yourself. All right. So in conclusion, mathematical studies offers a robust foundation for diverse career paths and the personal, professional developments. And so my challenge for you is that explore this world of mathematics. Don't limit yourself to one area. Embrace the challenges and unlock what? Unlock your potential in shaping the future. So just for fun, because the team says playing with mathematics, I've gathered a lot of movies that I felt like if you want to inspire you inspire yourself, aspire to inspire. If you want to have more ideas of how maths it's been utilized in different areas, watch these movies. Queen of Katwe, Hidden Figures, Fatland, The Beautiful Mind, Brad Pitt, Moneyball, uh, the Martian, and there's this other one, the Man with an Infinity, and then Donald in Magic Land. There are a lot of them. These movies will inspire you to do what? To pursue more interest, to see the essence of what you are doing, to see the essence why we encourage you to study maths, why we are saying this is the benefit, this is the importance, these are the value. You will see the applications. All right. And that is it from me to you. I wish you all a happy Pi Day celebration. You're welcome to reach me at any time through the coordinator and through the other faculty mentors. I must extend my greetings to all other faculty members at Mathematics World of Excellence, the faculty members at Nandezikwe University, Department of Maths. My friends over there, I know they are watching, and it's good. It's good to see you. We had to do this because we don't know how the network is going to be during the event. So we had to do this video recording ahead. And that is it from me. Congratulations once again, Professor Eric Ofedu, on the launching. And then enjoy the rest of the activities. I hope you have been, your interest have ignited that passion, that interest for you to explore this world of mathematics. Do have a lovely celebration of International Day of Mathematics and enjoy some pie for yourself. Bye and see you some other time.